In this video, we shall be using CAP697 for the multi-engine piston aeroplane, and I shall be showing you how to obtain the fuel time and distance to descend using figure 3.6. And this is figure 3.6. The way we use this table is very similar to obtaining the fuel time and distance to climb. And just like that chart, you may have to do the procedure twice, once for each altitude, and then calculate the difference between the two sets of values. Now this chart already has a work example illustrated through. We shall use a different set of values so that you have an example that you can come back to and see if you can work out and whether your answers match the provided solution. In our example, we will assume that our multi-engine piston aircraft will be descending from an altitude of 14,000 feet, where the outside air temperature is 10 degrees Celsius, and descend to an altitude of 4,000 feet, where the outside air temperature is 24 degrees Celsius. So let's see how that's done. We'll first enter the chart from the temperature scale for outside air temperature, move up to intercept the altitude, and then we'll move across the chart to obtain fuel, time, and distance for each of the altitudes. So I have a fuel, time, and distance line here, but I have a fixed unit scale at the bottom. So when we move down from the fuel, time, and distance lines, actually these units will be converted into gallons, minutes, and distance in nautical miles. So let's see how that's done. We'll first plot the lines for 14,000 feet where the outside air temperature is 10 degrees Celsius. So here's where 14,000 feet intersects 10 degrees Celsius outside air temperature. We next move across the chart, and I'm going to draw a line that will cut all three lines for fuel, time, as well as distance. And that should look something like this. So I've intersected the fuel line, time line, and distance line. And now to get the fuel, time, and distance for the first plot, we simply move down the chart to the scale at the bottom. And that should look something like this. So what do these numbers mean? Well, these numbers simply mean that from an altitude of 14,000 feet, where the temperature is 10 degrees Celsius, if we were to descend all the way down to sea level, it would take us for just over 5 gallons of fuel, 10, 12, 14 minutes, and cover a distance of 32, 4, 6, 8, 39 nautical miles. So if we were to descend all the way to mean sea level, that's the fuel, time, and distance we require. Now, because we're not descending to sea level, we're descending to an altitude of 4,000 feet, where the outside temperature is 24 degrees Celsius, we're going to find out what is the fuel, time, and distance required for an aeroplane that is descending from 4,000 feet, where the outside air temperature is 24 degrees Celsius, descending to sea level. And we're going to find the difference between the two, since both aeroplanes, if they were to continue descending to sea level, the portion of the flight from 4,000 feet would be the same. Let's complete that so I can show you how it works. And this is what it would look like. So we would consume 1.5 gallons of fuel, take 4 minutes, and cover a distance of 10 nautical miles. In order to find the fuel that is required for descending from 14,000 feet to 4,000 feet, we'd simply find the difference between these two. So we're going to take our earlier values, which you can see in red, and we're going to subtract the corresponding smaller values, which you see in blue. So 5 gallons minus 1.5 gallons, 14 minutes minus 4 minutes, and 39 nautical miles minus 10 miles. So we would need 3.5 gallons of fuel. It would take 10 minutes, and we would cover a distance of 29 nautical miles to descend that difference of 10,000 feet. Now in this example, we have said that we are descending from 14,000 feet cruising to an airport at 4,000 feet, but this can be used for determining the fuel time and distance descending from one altitude to an intermediate altitude. It doesn't necessarily have to be for a landing aerodrome. And that's how we use figure 3.6, fuel time and distance to descend.